Good morning, everybody, and very welcome at this second Into Power webinar. Today, it's all about catching the perfect wave to test your product or your technology. I'm Katrien Kriel, and I'm your host today. I work for the POM West Flanders, which is the regional development agency of the province West Flanders in Belgium, and I work within the team Blue Energy. So before we're really going to start with this webinar, I would like to go through some practical arrangements together with you. And I will show my first slide. As you can see, this webinar will be recorded, so you will be able to see the replay afterwards. Also, we note that this webinar works best when you use Google Chrome. So if you would have any problems, just switch to that browser. Also very important is to know you can ask any questions you would like today. On the right side of your screen, you can see a chat function. So you can ask your questions and we will try to answer all your questions today. Also, our moderator, Celine, who is behind the scenes, she can answer your questions, and of course also our experts can do so. Please note that if we are not able to answer your questions today, you will be answered by mail. And you'll also have the opportunity to ask all the questions you would like during a Zoom session within 1 week. And I will come back later on that item. Okay, so this being said, we are very curious to know who is also participating at this webinar. And therefore, I will launch a poll. And if you give me 1 moment, normally when you scroll down on your screen, you should see following questions. Which role does your company have in the supply chain offshore wind? Is it maintenance, you're an installation, you are busy as a service provider, more like research and development? And I can see the first answers coming in. We have, especially for the moment, research and development. And I just wait 1 moment. Okay, I can also see that persons who are busy with the companies with installation. But most of them still research and development. Okay, so most installation indeed and research or development. That's the most important part I can see for this moment. Okay, so before we're going to listen to the experts of today, I would like to give you some more information on wave basins and wave flumes. Today, there are 3 test facilities that are presented, 3 types within the category of wave basins and wave flumes. So please note that within the Into Power project, we have made a dedicated web page on test facilities within the offshore wind industry from the Noordzee region countries. So you will find the link to that web page at the end of the webinar. So why should you go and test in a wave basin or in a wave flume? Well, at a certain moment, it can be very useful to set aside the calculations and the numerical models you have made, and you can compare the result of those calculations with real facts. So you will just step out of the numerical world and get into the real world. Also, if you decide to go and test in a wave basin or wave flume, it can be very important to have some more information on the test facility. So today, our 3 experts will highlight some elements, and they will be taken into account by those 3 presenters. And I will show my slides again. First of all, you have the capacity and instrumentation. It's important to know which is the volume. What is the size of the test facility? Which test can be executed? Which is the degrees of freedom of the test facility? Secondly, we also have services. It can be very important for you when you would like to go and test your technology to know which services can be provided by the test facility. Also, this item will be taken into account by the test facility owners. And last, we have under a general header, practical information. So which applications can be tested? Also, for example, what is the lead time to go and test your product in the test facility? So all these elements will be taken up by the experts today. So for now, I think we're totally ready to switch to the first speaker of today. We're going live to Mr. Patrick Peters from Flanders Hydraulic Research in Belgium.
Okay. Thank you, Katrien. Thank you to Into Power for providing us the opportunity to present one of our physical installations. When I'm going to my slides, I also have to push probably something. This is the previous one, and now I have to move to the next one. Katrien, am I doing well so far? I'm going to talk about our multi-directional wave basin. My name is Patrick Peters. I'm here standing on behalf of Mark Willems, a colleague, and Peter Trok from University of Ghent as well. You already see a picture of our wave basin, and please follow me the next 10 minutes to give you some more details there. Maybe before we go to this installation, a brief introduction to my of where I'm working. I'm working at Flanders Hydraulics Research, which is a governmental research institute. We hope that you all think of us as experts in the field of hydraulics, coastal structures, nautical aspects, and sediment-related, as well as hydrological issues. In our division, we have 4 research areas to cover. We have people looking at harbors and waterways, the accessibility of ships to those harbors. We have experts in the field of hydraulic and coastal structures. We have people dealing with water management in general on a catchment level. And then we have let's say experts again are really looking into the detailed behavior of water and sediment. Research at Flanders Hydraulics Research is performed by 3 instruments. In order to better understand reality, we aim to, let's say, deploy or execute numerical model simulations. We are using physical simulation tools as well as in situ measurements because we believe we have to combine them all 3. So this as a brief introduction to Flanders Hydraulics Research. You can see a picture of our entrance on this picture, and now I'm going to the multi-directional wave basin. First of all, regarding the capacity, our wave basin has a length of 25 meters more or less and 20 meters of width. We have a wave generator exist in place, which you can see in the back, consisting of 30 individual panels which can move individually, but they can also move together, of course. We are pretty confident and really happy that our generator can create state-of-the-art waves, including active wave absorption. We can generate regular waves, irregular waves. I will come back to that a bit later. We can create short crested waves, long crested waves, with any wave spectrum you are interested in. We can build in custom 3D structures or geometries, and we can apply waves on it, and we can measure wave forces. We can analyze overtopping volumes and hydraulic pressures, let's say. So that about our capacity. Of course, when you're doing experiments, you're not only watching the experiments, you're also doing measurements. We have measurements we just bought in the shop, but we can also develop our own measurements depending on your needs. Here in the front, you see a wave height measurements device. In the back right corner, it's in fact a box and where the overtopping volume is measured. And in the left top corner, you see some pressure transducers to come up with some wave data. What about our services? We are not just providing you the key and then it's up to you to our installations. No, we think along with you. We have hydraulic and coastal experts who can think along with you, and so we come up with the kind of smart design of a test. We can build in every situation or create every situation, more or less, you are interested in. And if special equipment is needed, we can develop them in our workshop. In addition to this physical installation, we also have, as I mentioned before, numerical tools. We have in situ measurement devices, so we can offer you the entire package, if you like. Now I'm going to show you a small movie of our wave basin in action, and let's see, what is it doing? Does this mean, Katrien, that nobody hears me now? So I cannot provide information on the film. Is it going, the film? Wait there. No. What is it doing? Katrien, maybe a question. Did you see the movie? But you didn't hear me. Because I wanted to explain a little bit.
Playing now.
It is still playing. And can I give comments on during the movie? Anyway, I don't see the movie, but let's stop the movie. I go back to the presentation because otherwise it's going to be I'm going to make a fool of myself. I'm here back at the presentation, and my last slide here now is and more or about practical issues or information. Let's say together with my colleagues, I think we can find an appropriate time slot for your experiments. Of course, it's not always available, and sometimes we know a large set of experiments are coming up. So if you have ideas, questions, I suggest to contact us and we look for an appropriate time. In addition to our wave basin, we have also wave flumes. We have a small one, a big one. And this allows cost-effective research because it's not always necessary to build an expensive 2D or 3D model in our wave basin if another tool can be used. And finally, I'm really happy to present you the coastal and ocean basin, which I'll show you a movie later, which we are realizing together in collaboration with University of Ghent and Leuven. And this collaboration gives you access to a large group of coastal experts. And also here, we maybe can provide you with a solution for your problem. So I'm now moving to the movie on the coastal and ocean basin, and there's sound with it. So I just shut up. Okay. You see the movie? No. Katrien, you have to tell me when the movie is finished. I can continue? No. So So it's really necessary to stay tuned until the end so we can make some publicity for another Interreg project, which is now on the screen somewhere. So the movie has ended. So I'll go back to my presentation. You hear me now? You see me now? So this was a small introduction to our new upcoming facility in Ostend, together with Ghent University and KU Leuven. So that's the end of my talk. I hope you have now some thoughts and you have an idea of what you can do with us later. And please see you soon.
Thank you very much, Patrick, for this interesting presentation. Be sure we will show the movie also of Flanders Hydraulic Research. Also, we send it with a replay, so you will be able to watch this movie also. I would suggest we just switch to the second speaker of today, which is Dr. Schimmels from the Coastal Research Center.
Yeah, thank you very much, Katrien. And good morning to everyone who's listening and watching. I saw in the list of viewers some familiar names, but to those of you who are not familiar with the Large Wave Flume and with the Coastal Research Center, I would like to introduce that to you now within the next 10 minutes. And as we just ended with a video, I would just like to start with a video so you get a short impression of what I will explain you a little later in my presentation. So I will just start the video. See you back in 2 minutes. Okay, perfect. So I hope, you enjoyed the video. And what I would like to do right now is to give you a few more details about, well, the Coastal Research Center, but in particular, the Large Wave Flume, so our core facility, and what we might be doing for you. So I will switch to my presentation. Press the wrong button. So a short introduction to the Large Wave Flume, or as we say in German, Großer Wellenkanal, GWK. That was planned and built within a large research project in the 1970s, basically. It was constructed in those days, so in the end of the 70s, beginning of the 80s, for a total cost of 20 million German mark, or 10 million euros nowadays. And it is in operation since 1983. And in the first 12 years, there was another big research project in which the large wave flume has been used, in particular for coastal engineering purposes, so dikes, revetments, sediment transport issues, and so on. And after that big research project ended, well, in 1995, the Coastal Research Center, or Forschungszentrum Küste, FCK, was founded. And just to give you a short idea, so here you can see that in 1996, we were founded as we are today, and you see that we have a board of directors. So we are an institution belonging to 2 universities, the Leibniz University of Hannover and the Technical University in Braunschweig. And here you see the board of directors made of 4 professors from 4 different institutes. Probably the lower 2 ones are familiar. So Thorsten Schlumann on the left-hand side from Ludwig-Franzius-Institut and Niels Goseberg from Leichtweiss-Institut are probably familiar to some of you, as they are dealing with coastal engineering and offshore engineering. So let me tell you some facts about GWK, the large wave flume. So it is a facility, a quite big facility, and we used to say that it is, well, the biggest facility of this kind worldwide, up to recently. So we have a total length of 300 meters, 5-meter width, and 7-meter height. We have a piston type wave maker with active wave absorption, and with that we can also generate basically any kinds of waves, so from regular waves up to 2-meter height, or irregular sea states up to 1.3-meter height. So keep these numbers in mind, because in the end you will see that I'm a little bit talking about the past. But just to give you an idea, we also have extensive instrumentation. So as we heard before, so from wave gauges to velocity probes, pressure and force transducers, up to more sophisticated technologies like 2D, 3D laser scanners, videos, and so on, for sure. So what are we dealing with in the large wave flume? So what are typical projects? So classically, you see on the left-hand side, this is classical coastal engineering topics. So from coastal structures, as I mentioned before, to sediment transport. That's the areas that we are dealing with since the very beginning. Then a new topic came up recently, which we call eco-hydraulics. So it's the interaction between waves and plants in our particular case. And this is maybe most important for today. That's exactly why I would like to give you some examples, is the area of marine energy, which covers basically offshore wind energy, but also wave tidal energy. So what have we done in the past? Just to give you an idea. So in the area of wind energy, we have investigated several different foundation structures with the main objective of providing data for certification issues and so on. So you see some examples in those pictures, and the main objectives were wave loads on those structures, or breaking wave loads in particular. So things where scale matters, as well as scour development and protection, scour protection. But also we had a couple of projects related to wave energy. As you can imagine, there we had also different project objectives, which went from fundamental research to applied research, for technology development up to, well, TRL or technology readiness level 4. So this is surely something we could offer to you. And we mostly did model tests with fixed devices, as you saw before, but also we can test floating devices, and we have done that before in our flume. Just some few slides to give you an idea about the well, occupancy and what happened in the large wave flume. So here you see a kind of statistics that we had in the last 3 years. So from 17 to 2019, we had in total 18 projects, which were made up of more than 700 user days, so days in which the large wave flume was actually used by projects, which is a total occupancy of about 95%. So we are pretty busy with our flume. A typical project, so on average, a typical project duration is about 34 days, and more or less only 1/3 is actually test days for that. Also, you see in purple, that's the marine energy project. So we had 3 projects in total, which is more or less on the average, but that only made 5% of the user days. Yeah, here also the distribution of the number of projects, you see that in 2018 and 2019. In particular, we had marine energy projects, and those were basically made up 15% in 2018, but only 5% in 2019. Yeah, what I want to, well, tell you right now is that right now we cannot offer you anything because we are out of operation as we are upgrading our flume. So sorry for that, but you will see here, or you do see here, that it is worth waiting a while, because when the upgrade will be finished, we will have a new wave maker which can generate even higher waves and longer waves, so we can increase the scale of our experiments. We will also have, in addition, a new current generation, so that we can simulate tidal currents, for example, and we will have a new staggered deep section, so that we can install a sediment or the seabed flush to the rest of the flume. Just to give you a short impression, that's how the new wave maker more or less will look like. We will always have, almost have more or less double of the stroke available, as you saw before. That will increase the wave height, but also the wave length. Here is some impression of the current generation. On top, you see a top view of the wave flume, and below you see a side view. And you can realize that we can generate the currents in both directions, as I said, with a total discharge of 20 cubic meters per second, yeah, which is quite something. So, for example, at 4 meter water depths, that would generate a current of about 1 meter per second. And eventually also the new staggered deep section, staggered in that sense that we have a part which is 28 meters long and 2 meters deep. You can see here on that image that this will enable us to install seabeds flush to the rest of the flume. And yeah, inside that there's an even deeper part which is 6 meters deep, and which shall be used for installing offshore foundations, just like in nature. So we don't have to fix them artificially, but we can just drive them into the soil. Yeah, so what's the current status? As I said, we are right now out of operation, and well, construction works have just stopped, so you don't hear any background noise right now. So the wave maker is already in is already manufactured. The construction works have started a few weeks ago, more or less, and they will be finished by September 2022. Below you see an image how it looks like more or less right now. So parts of the flume have already been removed. So for the inlet and outlet of the current system, and this is ongoing work. You can also follow that via that link, which is shown in there. And cross fingers that everything will work well and everything will be finished by September 22. And if you remember the end of the video, which I've shown at the beginning, I would be very happy if you join us again in 2023. Thank you very much.
So thank you very much, Dr. Schimmels, for this also very useful presentation. So let's go to the last speaker of today, which is Marijn van Rooij from UGent Grazers, and he will present the wave flume of the University of Groningen. Let's go live to the Netherlands.
Thank you, Katrien. Welcome. And thank you for inviting me to give a presentation at this Into Power webinar. My name is Marijn van Rooij. My name is Marijn van Rooij, and I'm currently the CTO of UGent Grazers, or Technical Director. I'm going to tell you about our own made wave flume at the University of Groningen, how to use it and where you can use it for. It's a bit different than the others, but just as nice. And this presentation is also a bit about the process of building an own small wave flume, relatively cheap and for fast prototyping and verifying concepts. Just to give you a brief introduction and some context, UGent Grazers is a startup company and founded as a research spin-off from the University of Groningen. We develop renewable energy technologies that are mainly focused for the offshore market, where our primary focus is on the development of the ocean battery, a sustainable energy storage device. And next to that, we also work on the development of the wave energy converter. We have the spin-off company founded in 2018, and parallel to that, still have the UGent Grazers research project running at the university. We are located all the way in the north of the Netherlands, where we call our small facility, where we have the wave flume, the water hole. It's basically a shed, but a very nice shed of roughly 12 by 12 meters, attached to the university building of the Faculty of Science and Engineering. The address is Nijenborg 4, and what is good to tell you is that the water hole and the equipment in there belongs to the faculty. It all started in 2014, where we as the UGent Grazers research project gain access to this place to do research on our hybrid wind wave storage device. And during the years, we have built experimental setups, simulation and models, prototypes, and done a lot of testing and so on. However, during the development of the wave energy converter, we got to the point to actually test the concept of our floater blanket. The floater blanket is a mattress of floaters that follows the motion of waves and translate it into a heaving motion for our PTO or power takeoff system underneath. To test this concept, we of course would eventually like to test this floater blanket with its PTO system in a bigger certified facility. But in this first steps of designing and testing the prototype, we really felt the need to test it first before going to these large wave tanks, for instance, to face some unexpected surprises. So in other words, do a proof of concept in-house, not to completely validate it, but more to see if it works. So we thought about it, had a cup of coffee, and a few minutes later came up with a brilliant idea. Let's build a wave flume ourselves. So it happens. In 2016, we started the construction. We listed the requirements and made some designs, did the calculations and strength analysis, and drove to the local do-it-yourself store. A lot of woodwork later, the structure was ready, and we first used some black EPDM foil to cover the inside and make it watertight. After completing this version, we filled it up with almost 6 cubic meters of water. We also had to design a wave generator that produces the waves in the flume, in which there are 2 common ways to do so. You can create waves that represent shallow water or deep water. For shallow water, you need a piston pedal type of wave maker that creates ellipse motions of the water particles and are suitable for testing coastal structures and harbors. And in this type, there is still a wave motion on the seabed because the waves coming from the open sea starts hitting the shallow seabed and got squeezed together, which accounts for the ellipse motion. However, our concept of the wave energy converter was focused on the more deep water waves, the ocean waves, where the seabed does not affect the motion of the water particles, and in which there is a orbital or round shape particle motion that decreases sharply with the depth. So the first version with the black EPDM foil worked really great, and not long afterwards we upgraded the wave flume to the version we have right now. It's completely sealed and covered with polyester resin. It's painted with a special watertight coating and has a size of almost 10 meters long, 80 centimeters in width and 80 centimeters depth. We can produce wave heights up to 15 centimeters with periods of 1 to 2 seconds. It has a absorbing beach with 30-degree angle to absorb the waves at the end of the flume and minimize the reflection back to the prototype, which you don't want because it affects your measurements of the prototype. And we installed 2 large acrylic windows in the side to view the prototype and also be able to record it from the side. We have the following instrumentation available if you would like to do measurements on a proof of concept level, so a low TRL stage. We have wave probes to measure the wave profiles and reflections. We have force transducers, pressure sensors, and displacement sensors to analyze and monitor the prototype in the water. A high-speed camera to record what happens through the side windows. And via another research division at the university, we have access to a method called digital particle image velocimetry, what can be used to analyze the motion of the water and see what happens with this motion if you are extracting energy from it. With this PIV setup, we fill the wave flume with very small particles, equal density of the water, and use a laser beam that produces a thin sheet of laser light to light up these particles. And with a high-speed camera, you can record it, and through a special-made software program, you can analyze the movement of the particles and thereby the movement of the water underneath the prototype. It's a very accessible facility at a low level entry, also because it belongs to the university. And via the university, students can freely use it to do research and experiments. And we as company Ocean Grazer can use it as well, but everything should be in coordination with the facility. Unfortunately, we cannot access it today due to the COVID-19, where the university closed all buildings for third parties and students. But hopefully somewhere next year it opens again. What is very useful for you, I think, is that it is based on the university. So experts or professors are ready to help you with fundamental research and also to start collaboration if necessary. So I've already talked about the main application to use it for. So the one why we have built the wave flume, and that's for the proof of concept testing of our floater blanket. The blanket is made up of 10 interconnected elements, each connected to a piston pump that acts as a power takeoff system. We created simulation models and tested it in our wave flume with this setup. We also use it to test the first designs of the ocean battery. It's a storage technology that uses the hydrostatic pressure of the ocean to store potential energy. And we use the wave flume for testing suction anchor technology, in which we have poured in a lot of sand at the bottom of the wave flume and start testing with the suction anchors. And once we had a PhD student from Loughborough University that used the wave flume to test their concept of a flexible type wave energy converter. And she used the flume and also the PTO system at the site to do so. Thank you very much for your attention. And if you would like to learn more or to know more about this facility and also the possibilities for you, then you can always contact me. Thank you.
Thank you very much, Marijn, also for these interesting presentations. So before we're going to close down this webinar, I would like to launch one other poll, and give me one moment. I will launch the second poll, and it concerns the question at this moment, if you have heard all the explanations of the experts, which test facility would suit your needs best at this moment? So when you scroll down on your screen, you should be able to see that question. And I can see also, again, the first answers coming in. Also, we have Multi-Directional Wave Basin, who is quite leading for now, but also large wave flumes and the wave flume from the Netherlands, I can see it's shifting a bit. But also some people who say, I would like to have some more information. I will wait one other minute. Okay, it's quite equal, I can see. Yes, but quite a lot of people also need some more information. So at that moment, it is perfect just to explain once again to you that you will be able to ask your questions during the Zoom session and the breakout sessions within 1 week. So within 1 week, the 25th of November, same time, you will be able to ask all the questions you would like to the experts at any stage your project would be in right now, or you're still starting with a project, you already developed a project, it's no problem. The experts can answer all your questions you would need. So I think for now, this webinar is almost finished. The only thing I can do is thank you very much for your participation today. Please note this webinar is one item of a series of webinars. The first upcoming webinar will be the one on cabling testing test facilities. So I just would like to say also that the link to the Zoom meeting and the breakout sessions will be sent together with the mail of the replay. So all thank you very much, and I'm really looking forward to seeing you very soon or during the breakout sessions or for the next webinar. Please have a very nice afternoon.